Welcome to Lesson 20. This is our last lesson of the semester, where we're going to continue talking about factoring. I introduced that concept in our last lesson when we talked about greatest common factors, and we learned that factoring means write as a product. So before we start factoring, let's just quickly review how we multiply two binomials. We've learned in the past that we can use the FOIL acronym to help us remember to distribute. We multiply the first, the outer, the inner, and the last terms. And then we usually have to combine like terms, and so in this case, the 4x and the 3x give us 7x. So we just multiplied those two binomials, and we ended up with a trinomial. In this section, we're going to be working backwards. When we factor, we're going to start with the trinomial, and we're going to try to find the two binomials. So there's a couple of patterns that we're going to need to pay attention to. Notice that this last number, the 12, came from multiplying the 3 times the 4, and the 7 came from combining like terms, where we had to add a 3 and a 4. So basically, when we factor, we want to find two numbers that give us a product of that last number, but a sum of the middle number. So let's do some examples. If I want to factor x squared plus 6x plus 8, this is a trinomial, starts with an x squared, so I can factor it as x plus a number, x plus another number. To find those numbers, I need to try to find two numbers that have a product of 8, the last number, and a sum of 6, the middle number. So to do this, I'm going to start by thinking about what kinds of numbers have a product of 8. And I'll just make a list. It could be 1 and 8, or 2 and 4. Those are the only possibilities. And then I check, well, which one of these adds up to 6? The answer is the 2 and the 4. So that tells me I can factor this as x plus 2, x plus 4. Now the great thing about factoring is you can check your answer. You could use FOIL and multiply this out to make sure that you get the right answer. If I were to use FOIL here, my first is x squared, my outer is 4x, inner is 2x, last is 8. And if I do combine like terms, notice I end up with the exact same trinomial that we started with. That's how I know that I've done the problem correctly. Now, I typically don't check, and you don't have to check, but it's nice to know you can if you're taking a test and you have some extra time. All right, example B, we want to find two numbers with a product of 9 and a sum of that middle number, which is negative 10. Because this problem starts with a y squared, I know that my factors are going to have y's in them. That'll give me the y squared. So I always start by thinking about the product part of the problem. To get a product of 9, I have two possibilities. It could be 1 and 9 or 3 and 3. Now actually there's more possibilities than this. If we think about negatives, it could actually be a negative 1 and a negative 9, or a negative 3 and a negative 3. If both numbers are negative, you also get a positive product. So which one of these adds up to negative 10? Well, negative 1 and negative 9 do. So my factors would be y minus 1 and y minus 9. Notice that if the product is positive, both signs have to be the same. If you have a positive sum, both are plus signs. Negative sum, both are minus signs. Example C, we want a product of negative 30, a sum of negative 1. So now we have a negative product. That tells me one number has to be positive and one has to be negative. So I'll make my list and then I'll deal with the signs later. Let's see, it could be 1 and 30, 2 and 15, 3 and 10, 4 does not go into 30, 5 and 6. But one number has to be negative. If I want my sum to be negative, which I do, it's the larger number that has to be negative. And so once I have my list, I can go through and check which one of these adds up to negative 1. That would be the 5 and the negative 6. So my final answer would be x plus 5 and x minus 6. Now the order you'd write your factors in doesn't matter. If you had written on your paper x minus 6 and x plus 5, that would be equally correct. The order of multiplication doesn't matter, so the order you put your factors in doesn't matter either. Okay, example D, product of negative 70, sum of 3. So one number has to be positive, one has to be negative. So let's see, well, it could be 1 and 70, 2 and 35, can't divide by 3, can't divide by 4. It could be 5 and 14, can't divide by 6, 7 and 10. Now this time I want the sum to be positive, so the smaller number has to be negative. And which of these add up to positive 3? That would be the negative 7 and the positive 10. So my final answer would be x minus 7 and x plus 10. Example E, we want a product of 5, sum of negative 7. I always start with the product part and make a list. Let's see, 1 and 5, those are the only things that give me a product of 5. But a negative sum, so both numbers could be negative, that doesn't add up to negative 7. And there are no other factors of 5. Since I made a complete list, and the only factors I have don't add up to 7, that tells me that this polynomial actually can't be factored. Not every polynomial can be factored. And in fact, we could say that this is a prime polynomial. Just like when you have prime numbers, it can't be factored. Now, sometimes we might have to combine the methods from last week with these new methods. Example F is a little bit different in that there's a 2 in front of that z squared. The first term has a 2 in front of it. This problem is also different because it has a greatest common factor. And in fact, if you are factoring, the very first thing you should do in any problem is check and see if there's a common factor. Is there a GCF? And in this problem, everything is divisible by 2. And so the first thing I'm going to do is pull out that 2, and I'm left with z squared plus 10z plus 16. Now I can use the new technique that we just learned and try to find two numbers with a product of 16 and a sum of 10. So let's see, it could be 1 and 16, 2 and 8, 4 and 4. There we go, the 2 and the 8 add up to give me 10. So for my final answer, I have to keep that GCF, that 2, in front of the problem, and then it would be z plus 2, z plus 8. All right, let's do one more trinomial. The very first thing I'm going to do, no matter what, is look for a GCF. Is there something I can take out of all three terms? Well, in this case, all three terms have an x in them. That's my GCF. If I pull out the x, I'm left with an x squared plus 19x plus 60. Now I'm going to use the new technique. I need to find two numbers with a product of that last number 60 and a sum of the middle number 19. So I would go through and make a list. You don't have to make the list if you know the numbers right away, but I think it's nice to be systematic. Make sure you didn't miss anything. So 1 and 60, 2 and 30, 3 and 20. There it is. 4 and 15 add up to 19. So for my final answer, that GCF stays there. It stays in front of the problem. And then I'll put in an x plus 4, x plus 15. All right, so to factor trinomials, we look for a GCF, and then we have to use this product sum technique to factor. Now I want to show you one more type of factoring, and that's factoring a difference of perfect squares. We learned in the past that if we multiply, or we FOIL out, a plus b times a minus b, we end up getting a difference of perfect squares. The inner and the outer terms cancel out. So this formula basically says if we want to work backwards, if I have something like x squared minus 4, 4 is a perfect square. 4 is the same thing as 2 squared. So this formula says we can factor this as x plus 2, x minus 2. That's my difference of squares formula. Another way of thinking about this, the x squared minus 4, your product is negative 4, and because there's no middle term, your sum is 0. So 2 and negative 2 are your numbers. So let's take a look at a couple of examples. Y squared minus 9. 9 is the same thing as 3 squared. So this is going to be y plus 3, y minus 3. Now this technique works, this formula works, even if there's a number in front of the x squared, or in example B, the c squared. 25 is a perfect square. It's 5 squared. Since 25 is 5 squared, I know that my first term will be 5c. And then 4 is 2 squared, so it's going to be 5c plus 2, 5c minus 2. Now what about examples C and D? Well, 18 and 32 are not perfect squares. However, anytime we're factoring, the very first thing we should be doing is actually looking for a GCF. And that might actually help us with this problem. 18 and 32 are both divisible by 2. We can pull a 2 out front, and we're left with 9x squared minus 16. Now we have perfect squares. 9 is the same thing as 3 squared, and 16 is the same as 4 squared. So it'll be 3x plus 4, 3x minus 4. Notice that the GCF, the 2, is still part of that final answer. All right, one last example in part D. Well, I always look for GCF first. And both of these terms are divisible by 5. So if I pull out a 5, I'm left with a z squared plus 4. Now in this case, we actually can't go any further. We can't go any further because of that plus sign. Our formula is only for a difference of perfect squares. If you see a sum of two squares, a squared plus b squared, that cannot be factored. And so this is my final answer. I actually can't go any further with this. If we had a minus sign there instead, then we would definitely use that difference of squares formula. Okay, so to summarize, when you are factoring, very first thing you're going to do is look for a GCF. Then, if you see only two terms, you're going to check, are they perfect squares? And do you have subtraction? If so, you can use our formula. If you have three terms, a trinomial, that's when you're going to use that product sum method. All right, that's it for this lesson. Let me know if you have any questions. And in this module, you should be able to find some final exam review problems as well. The final exam is going to cover everything that we've talked about this semester. So I would suggest getting started with your studying as soon as you finish this module.